Okay. All right. Well, let's get started. Happy Monday. Happy week 7. I hope you guys are all doing well. Those of you who are watching the video, I hope you are doing well. I miss seeing you guys in class. But yeah, I hope I hope you're following along and learning. Again, as you're working on your final projects, I anticipate your groups will encounter some issues with your data or have run into some kind of thing where you're trying to do something and you think you know how to do it, but you're not 100% sure. So again, please come to office hours, and maybe you guys are doing fine, but you just kind of want a little bit of guidance and just make sure you're heading in the right direction. Come to office hours. I will try to help you. Okay. I do want to talk a little bit about our exam. So we have an exam 1 week from today, 8th week Monday, and it's going to be online. So don't come to class. Yeah, you know what? I'll post a little bit more instructions and clarity, but I'm going to ask you to log in on Zoom. So it's going to be a timed window, okay? So everybody's going to take it at the same time. And the way we're going to proctor the exam, even though it's like you're doing it at home, we're going to like loosely proctor it, and I'm going to proctor it using Zoom, okay? And that's just to kind of prevent people having like exam parties where you're like hanging out with your friends and you're all working on the exam together. So it's gonna, I'm gonna ask you to log in on Zoom with your cameras on, and that's just to kind of make sure you're kind of working by yourself. The exam is gonna be open note and open book, so I'm not worried about you like looking stuff up on your computer and things like that. That's fine. But I just want to make sure you're working alone. So that's going to be kind of the point of asking you to log in on Zoom and doing it. Okay. The format of the exam is a little bit like the homework assignments, not the data camp homework, but like the homework where I'm going to post basically a PDF with instructions. I'll post an RMD file, an R Markdown document that you will fill out with your answers, and then you'll knit it, and then you'll submit your knitted PDF as your solution there, okay? I have posted last year's exam, okay, as kind of a guide to give you a sense of what's expected. Of course, this year's exam is going to be different, but certain elements will be similar in that, I've posted a couple CSV data files, all right, and so last year's exam, I posted CSV files from the Bureau of Labor Statistics, and we downloaded like consumer price index values, and we looked at like how has the cost of eggs changed and things like that, and I ask questions like, take the table, okay, join the food prices and the items names table, and so you can kind of join them on the item ID, and it says okay, in 2008 month 1, so that's January 2018, a dozen of eggs was $1.77, okay, and then in March 2018 was $1.83. And then as time went on, the price of eggs changed. And so this, I said, make a plot, okay? Draw a plot of basically how the cost of items have changed over the course of time. And so this is what it kind of looks like. And so, in 2018, a dozen eggs was around $1.80 or whatever it was. And then I guess in sometime in 2019, it was less than $1.50 on average, and then in 2022, a dozen eggs went over $3. Okay, and so that's That's what we saw. The cost of ground beef, this is what it looked like. There was a spike in the cost of ground beef in mid 2020, around kind of during the pandemic lockdown. Around like May and June of 2020, the cost of ground beef had spiked, and then it came back down, and different elements, and you can kind of see how the cost of whole milk or low-fat milk changed, and the cost of boneless chicken breasts changed, and stuff like that. Okay, so that's part of the other thing. I said this was kind of these were the instructions. I said, make these plots and stuff like that. Okay, make bar plots, and here we rotated the thing and added some text and whatnot. So yeah, these are the kinds of things that I will be asking you to be able to do on the exam. Is I'll post some kind of data file, and I'll ask you to do some basic data analysis, some exploration, some create a plot. Over here I also said, okay, calculate what was the average cost, okay, of items. All right, so I said find the baseline cost. So look at the cost of items in 2018 and 2019 and take the average cost over that time period, and that's going to be our baseline cost. And then so if you look at a dozen eggs, the average price in 2018 2019 was around $1.57. And then I said, okay, now let's see how much that changed between to say October 2022. And so in October 2022, the average cost of a dozen eggs was around $3.42. So that reflected 118% price change in the cost of eggs. Okay, whereas tomatoes, the cost of tomatoes from 2018, 2019 to 2022, only went up 5 cents, reflecting maybe a 2.6% change or something like that, right? And so these are, I asked students to do some calculations, for these things. And so these are the kinds of things that I want to make sure you're comfortable with. So you need to be basically creating visualizations using ggplot. So creating, scatter plots, line plots, bar charts, bar graphs, or, geom column. That's going to be an important thing. I know with ggplot, there's a whole bunch of different exotic geometries. You're responsible for, I would say, the basic four. Scatter and column will be, I would say, the primary two, and then kind of related to that would be the line and the bar. Okay, so geom scatter, geom line, geom bar, geom column. Those are kind of your four geometries that I expect you to be familiar with, and you should be okay with changing the color, changing the size, changing the shape of points and things like that. And then you also need to be okay with kind of manipulating the data, manipulating in terms of like pivoting the data to be longer or pivoting wider, doing a group by and finding summary values, which is what we did here. I said group by these item names and calculate the average cost to kind of form a baseline cost. So things like that, possibly mutating, to create new columns. Here we have a cost change or value change, calculating things like that. So that is that's what you need to be comfortable with. You need to be comfortable being able to work through this at a reasonable pace. Okay, so I guess depending on how comfortable you are with this, you have around about 2 hours for the exam. Okay, you're gonna have about 2 hours. I'm gonna present this. It's gonna be the length of the exam will be comparable to this. Again, the questions and the tasks that you have to do will be different, but you need to be familiar and comfortable with that. How should you study? This is a tough question. So I've been assigning data camp homework, and so one thing about data camp is that it's very good for kind of like introducing things, but the outline is, it's kind of just like fill in like one or two missing words here, right? And so that's kind of the assignments. I think data camp has additional stuff called, here, let me move my sign, let me sign in. Whoops, don't want to purchase, I want to sign in. So if you go to learn, I think thing doesn't exist. I think they have something called projects, but no, maybe they don't. Okay, all right. Well, I'm currently having some trouble with. Okay, introducing unguided projects. Okay, so I think you can do some unguided projects here. So I guess there's guided and unguided. Okay, so you can look at some of these things. Yeah, maybe guided is gonna start off, but let's say we want to. You can look at data manipulation with R. Okay, so we'll do that, and I guess introduction to data camp projects. You can start there, and actually I haven't tried any of these out. But I think, let's see, if I were to start this, there's going to be a couple of things. So load the readr and dplyr packages, which is taken care of when we do library tidyverse, and then you'll load the data set, and okay, and so this gives you a little bit of code to kind of work through. Okay, and so these are some examples that you can kind of work through on data camp. You can also kind of revisit some of the homework problems and whatnot, but and also as you're working on your projects, just ask yourself, hey, can I figure out the average of this thing, or can I group by these variables and do stuff? So so your best kind of way to study is not by reading, but by doing. Okay, so if you just say, I'm going to read through the slides, I mean, that's could be helpful, but perhaps a better challenge will be to look at a slide and say, hey, can I recreate this graph? Okay, and in the beginning, maybe some of the code is up on there and you just retype some of the code, but that's also helpful if you revisit some of our older lectures. So if you say, okay, here is look at some of the earlier lectures about, all right, here's geom column and geom line. Can I create this, right? And can you create this without necessarily looking at exactly what the values are, right? So you're gonna have to kind of get the data in and create plots. So right, if you copy this thing to get your data, can you create these plots, okay, as needed, right? Some, I guess, see if you can try to recreate some of these visualizations. See if you can recreate some of these wrangling summary tables and whatnot. So if you do like mutate or group by and summarize, see if you can recreate some of these things without necessarily just copying every single line of code. Okay, so I would say that's a good way to familiarize yourself. It's your job will be to do work with the data in R. Okay. All right, any questions about that regarding the exam? What you can expect there? Okay. So you can look. So on the sample exam, I have kind of the output that you can expect to have. I didn't give you the answers of like this is the exact code to produce this. Okay. So but you have the prompts, you have the data files, and you can kind of check and see like, am I doing this correctly? Am I able to produce the outputs that appear here? And I think I have like this output is required for full credit, and then if you do this output, you get like some extra credit, right? If you make it a little bit prettier, and you can expect, I guess, it's kind of a similar format for the actual exam. And again, time yourself, and when you time yourself, I think it'll reveal to you like areas where you can practice and improve. All right, today I wanted to take a look at another group's data and do just a little bit of analysis there. And so my hope is that, one, that this is useful and helpful. Apparently there's a new version of RStudio out, but I will not update at the moment. So let me do a remind later. Okay, so this group's data came from the city of Louisville, and it's an animal shelter. Okay, so this is data.gov, and so this is kind of a official data set from Louisville Open Data, and unfortunately the data description is very tough to read, but you can download the CSV file. And this data set, and I will go ahead and I will load this up here. Here, let me turn the lights off again. Oh, let me give you your first view quiz answer. First view quiz answer is the letter C. C as in cat. C as in cat. Okay, so I'll load up tidyverse, and then I'm going to load up this CSV file. So says it's not in there, let me just set my source file location. All right, let me try again. Okay, there we go. So this is a data set coming from animal shelters in Louisville, Kentucky, and it has information about kind of all of the animals that have gone through the kind of the shelter system. So this will be animals like stray animals that were found. You ever watch Lady and the Tramp? Just like you have the dog catcher going out there, and they portray the dog catcher as the villain in the, well, not the villain, but yeah, kind of a little bit, right? But some people, they go out and there's stray animals, and want to make sure that the animals don't get hurt or run over or things like that. So they catch them and they bring them into the shelter, and we hope that animals get adopted, or their owner comes back and retrieves them. So it has information like stray that was found in field, and we also have information about in this case it was a dog, and then we have animals that are cats. And there's different things. Some of these, if you read some of these, they're a little bit sad, right? Like this animal was abandoned. We have foster pets, and you can read a bit more about these things. SNR is spay, neuter, release, and so this is like a stray cat was caught, and it's fine that the cat is kind of living out there on there, but they don't want this cat to reproduce. So they catch the cat, they spay neuter the cat, and then they release it. Okay, so there's a whole bunch of different reasons for animals entering and exiting the shelter. Also, inside this data set is if an owner loses their animal, they might contact the shelter and they'll put out like via the web, they'll enter in animal lost, right? And so the shelter will then be aware that a family or an owner is missing their pet, and they have a record of that as well. So this, I think, was collected over a few years, and so there's lots of observations, 47,000 observations. And so here, just wanted to start doing some initial exploration of the data. And so I thought, well, you know what, let's take a look at the N-type. N-type is there's intake and then there's outcome. So when animals go into kind of the shelter system, that's part of intake. And I just thought, okay, well, let's look at what are the values that we have for intake. So here I'm going to just create a bar plot. I'm going to say we're going to set our input intake as our x variable, and let's create a bar plot. And if I just do this is the plot that gets created. And I guess in this case it's fairly easy to read, but earlier, but if your plot window is too small, the words overlap, and so it becomes hard to read. So one thing that can be helpful is if I take this text and I just rotate it. Okay, so I'm going to rotate the text, and that can be done by using this option on the theme, and I'm going to do axis text.x, kind of saying we're going to change the axis, the text on the x-axis, and we're going to change the angle to 90 degrees. And vertical justification, so the default, this is what it ends up looking like. So here I've rotated it, okay? And what I want to do is, if you look carefully, I don't know if you can see, but the words are just, the tick mark is here, and the words are like to the right of it, the tick mark a little bit, and that's handled using vjust is equal to 0.5, and then here I'll leave hjust off, and so if I do this, you can see how the words are now centered at each tick mark. Okay, and then I'm going to add hjust and create this plot, and that makes everything right aligned. Okay, so here let me just expand this. So this is with hjust equals 1, and you can see everything, the words are aligned so that the right hand side of the word, when it's rotated, is right up against there. With hjust off, you can see the words are centered like this, and then with vjust at its default value, you can see the tick marks in the words don't quite align. Okay. As you do stuff in RStudio and with R code, a lot of times you're going to go on the internet and you're going to say, how do I do this thing, right? You're going to type in like, how do I do this in R? And you're going to find different kind of solutions. And you can use that, and you can kind of copy and paste it and adjust it to your needs. And that's fine. That's what a lot of people do. What I strongly encourage you to do is make sure you understand every element of that code that you are copying and pasting. So here, if you want to say like, okay, I want to rotate my text and I want to kind of make it look like this, you want to make sure you understand what it is that you're doing. Here I have angle equal 90. That kind of makes sense. What happens if I do angle equal negative 90? Okay, what happens? So here it rotates the text the other way, right? And so here I might want to do hjust 0, okay, and that's going to make it left aligned this way, okay? So depending on how you want your thing to be, make sure you understand some of the different settings and values that we have as far as the code that you've copied and pasted here. Okay, well anyway, here's the graphic, and again, my encouragement is as you're going through code, as you're working through it, make sure you understand each line that's doing. Okay. So here we see, okay, we have a lot of stray animals. We also have lost, we have foster, found, owner, surrender, return, things like that, okay? And here I thought, you know what, let's see how many of the stray animals are cats versus dogs, okay? And so I'm going to just basically take the exact same code, but inside the aesthetic mapping, I'm gonna add another element here, and I'm gonna say, let's change the fill color based on animal type. All right, so we're going to color cats different from dogs, and I do this. And this is the resulting plot, okay? And so we see, oh, you know what, there's actually a bunch of different animal types. We've got not just cats and dogs, but we have birds, guinea pigs, livestock, other, and rabbits, okay? And we see, you know what, mostly cats and dogs, right? Cats and dogs, these two colors, the yellow and the green, and it looks terrible on the projector up there, but these two animals kind of make up most of the things. And so, you know what, I kind of want to just take a look at lost versus stray and cats versus dogs. So I'm going to filter my data. Okay. And so here, what I'm going to do is I'm going to take the animal data set. I'm going to filter to animal type, percent in percent cat dog. Okay. And again, very, very, very important. If you want to see if it's like one of multiple, you use percent in percent. Do not do equals equals. Do not do equals equals. All right. Almost certainly on the exam, you'll have to filter to certain categories and things like that. And if you use equals equals, you're going to end up with the wrong answers. Okay. So we're going to look at cats and dogs, and then we're going to look at intake type, lost and stray. So we're only going to look at these two columns, lost and stray. And then and everything else I kind of left the same. We're going to do intake type on X. Fill type is going to be animal type, and we'll go ahead and plot that. Okay, so this is just, we're just basically zooming in on this column and this column, okay, just for cats and dogs. So now I just have these two colors, cats and dogs, and we're going to do that, okay. And I'm curious, okay, are there more, for the lost animals, are there more dogs than cats? Or for the stray animals, are there more dogs than cats? And so I want to look at kind of the proportion of lost animals that are dogs, the proportion of stray animals that are dogs. Okay, so just kind of comparing these two animal types, what are the proportions here? So visually, how would I change, rather than looking at the total count, if I wanted to change it so the proportion, we're looking at proportions, what would I do here? So I want the total height, the height of the total bar I want to be basically 1, right, for 100%. And then we're going to basically I'm going to just take this column here, I'm going to just stretch it up so it's the same height as the other column. And how would I do something like that? Here I'm going to do position equals to fill, and we're going to put that inside geom bar. Okay, so under geom bar, we're going to do position equals fill. So these are the kinds of things that you should be capable of doing for the exam. You know, if I said, hey, I want to make some kind of plot where we're going to get the proportions stacked up, right? So here we can see, all right, stray animals, we have cats and dogs. Lost animals, we have cats and dogs. When we look at the proportion of lost animals that are dogs, we see, what is that proportion? It's over 50%. Over half of the animals reported lost are dogs, okay? And if we look at the proportion of stray animals that come in, that proportion is a little under 50%. Okay, so we see there's a difference in proportions. Okay, so that's a helpful thing. And what we want to do, and if you are doing something like this with your final project, so certainly this group, as they're working through their data, you should do a proportion test. But you might, depending on your data, you might want to do a proportion test as well, right? So, for example, if you're doing like baseball data or something, you might be curious, like, what proportion of my players are left-handed versus right-handed or something like that, right? I don't know. That may or may not be of interest to you, okay? And you could say, all right, let's look at pitchers, all right? And looking at starting pitchers, what proportion of starting pitchers are left-handed? Okay, what proportion of relief pitchers are left-handed? What proportion of batters are left-handed? And is that proportion the same, right? Or is it very different? The general population is probably 10% or a little under 10% left-handed. But in baseball, there's a lot more left-handed people. Like being left-handed in baseball is like, makes you more of an asset, right? So a lot of these great pitchers are left-handed pitchers, and left-handed people, show up in much greater proportion in baseball. But is that proportion, universal across the board? So that, that could be something. And the question in statistics is, when we see a difference, like 60%, if I'm just eyeballing this and saying this is 60% and this is 48%, is that difference significant? Is this statistically significant? Versus, could it be a result of randomness, right? If I took a fair coin and you took a fair coin and we both flipped the coin, 100 times, are we going to get the same proportion of heads? Not exactly, right? If I flip the coin 100 times, maybe I get 53% heads, okay? If you flip the coin 100 times, maybe you get 46% heads, okay? 53% versus 46%, I would say that difference is not statistically significant, because we could fully understand how a fair coin could end up being 53% heads after 100 flips, and we could also fully understand how a fair coin could end up being 46% heads after 100 coin flips. So a difference between 53% and 46% in 100 coin flips, that would not be statistically significant, okay? If I flip the coin 100 times and let's say now we get 2 coins and we don't know if they're fair coins or not, all right? And you do one thing and you flip the coin and you get 70 heads, and I flip the coin and I get, 50 heads, okay? Now there's a lot more compelling argument to say, this proportion difference, 70% versus 50%, that is significant. That I don't think we're working with the same coin. Whatever coin you have that led you to get 70% heads, there's something different about it than the coin I have, which got 50% heads. Like, my coin, I believe, is a fair coin. Your coin, I don't think is a fair coin, because getting 70 heads out of 100 flips seems really strange for that to happen with a fair coin. How do we want to generalize that question to something like this, okay? When we look at all of the lost animals and we're getting 60% of lost animals are dogs, and we're looking at all of the stray animals and we got something like 48% of the stray animals are dogs, is that difference, 60 versus 48%, is that significant or not, okay? And to answer that question, we do a proportion test. So in order to kind of get at that, we need to get a count. How many dogs do we have? How many cats do we have? How many lost animals? How many stray animals do we have? So I'm going to run this count operation. Okay, before I forget, second view quiz answer is the letter B. Okay. So what have I done? I've done animal. I'm taking our animal data set, which currently has 47,000 operations. I'm going to filter to just cats and dogs. I'm going to filter just to lost animals and stray animals. And then I'm going to group by those variables, the intake type the animal type, and then I'm going to say, give me a count. Give me a count. All right, is this okay as far as operations go and getting counts? All right, so can you guys see this? Here it says number of lost cats, 3,098. Number of lost dogs, 4,547. Number of stray cats, 13,524. Number of stray dogs, 12,473. Okay, so that's one way for us to get counts. So that's great. There's also another function in R called table. Table will create basically a two-way table. And so, so here, I'm going to take the same code, and rather than piping it into count, I'm going to pipe it into table. Now, one thing about table, though, is table looks at all of the variables that you are giving the function table. And so there's 18 variables in animal, and it's going to like consider all of the different in-field in subtypes and all of the dates and all of the surrender reasons, and it's going to try to like make a table of all of these different combinations, and there's going to be like way too many. So what's very important is you make sure you select only the columns that you want summarized. Okay, when you do count and you do group by, you don't have to worry about this because it's only going to it's automatically grouping everything. But when you do table, you have to only select the columns that you want. So in this case, we're going to select just that column in type and just the column animal type. So we're going to just reduce our data just to those two types. And then I'm going to say make a table. And then there's another optional function called add margins, which will do row totals and column totals. So this is, so it's the, basically we get the same summary that we did when we said count. Okay, so we say lost cats, but here it's in table form. I hope you guys can see it okay. And so we see lost cats, 3,098, lost dogs, 4,547, and because I did add margins, the total number of lost animals is 7,645. Okay, stray cats, 13,524, stray dogs, 12,473, and stray animals total 25,997. Okay, is that okay? Creating these summary tables, and if I don't include add margins, basically we get the table without the row totals and column totals. Okay, so so this is just a nice thing that you get with table. With table, you do add the margins. And it says, okay, here's your row total, here's your column total, which is going to be helpful for us when we do our proportion test. Okay, so when we look at this plot again, we see the proportion of lost animals is over 50%. The proportion of lost animals that are dogs, okay, is over 50%. So dogs make up over half the lost animals, but they make up less than half the stray animals. And the question is that proportional difference, is that significant? Is it statistically significant? Could it be the result of randomness versus could it? Yeah. So again, if I flip the coin 100 times and you get 53 heads and somebody else gets 46 heads, we would say that proportional difference of 53 versus 46 is not significant. Okay. On the other hand, if I flipped it 1,000,000 times and I got 53% heads, so I got 530,000 heads, and somebody else got 460,000 heads after 1,000,000 flips, now it feels like we're dealing with slightly different coins, okay? Because the idea of getting 530,000 heads is a little bit strange, right? Because if you flip it 1,000,000 times, you're expecting around 500,000 heads, maybe give or take 1,000, but going 30,000 additional heads is a statistical anomaly. You'll have to take my word for it with 1,000,000 coin flips, okay? And same thing with, getting 460,000 heads, getting 40,000 heads less than what you would expect of 500,000. that's going to be quite surprising. Whereas, with 100 coin flips, getting 3 additional heads, right? If you're expecting 50 out of 100 flips to be heads and you get 53, getting 3 additional is not that weird. Getting 4 fewer, getting 46 is not that weird. But getting 30,000 more or 40,000 fewer is strange. But anyway, we're asking the similar kind of question. This time we're looking at the proportion of dogs that are lost. So I'm going to do 4,547 divided by 76.45. That's around just under 60%, 0.594. And if I say, okay, what proportion of stray animals are dogs? I would do 12,473 divided by 25,997. Okay, and we're going to kind of compare these proportions. And so there is a function in R called the proportion test. And this proportion test says, okay, what are your X values for basically how many dogs do you have? And so there we have 2 proportions to test, right? 4,547 divided by 7,645 and 12,473 divided by 25,997. So I have to create kind of 2 vectors here. One is basically how many dogs I have in each category, and then how many total observations do we have for each category. So the first value will be lost animals that are dogs for X, and then the second value for X is stray animals that are dogs. Okay, and then for N is the total number in that category. So this is the total number of lost animals, 7,645. And then the second number here for N is 25,997. So that's going to be the total number of stray animals. Okay, and that's going to be my proportion test. And I want to make sure we understand where these numbers are coming from when we look at, say, this summary 2x2 table here. So I'm basically taking this number and this number, the number of dogs, and the sum here. Is that okay? All right, and so I run this. And this is the output. It says the 2-sample test for equality of proportions with continuity correction. That's the official name. And the data is 4547, 1247, 12473 out of 7645 and 25997. Okay. And it says your x squared, your chi-squared value is this, and you have this p-value of 2.2 e negative 16. So basically 2.2 times 10 to the negative 16. So you imagine 0.000, we got 15 zeros and then a 2. Right? So this very, 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 very small number, almost 0. Okay, basically 0.00000. I got 15 of these zeros and then a 2. So it's saying the probability of something like this happening by randomness, okay, is practically 0. Right? The null hypothesis is that lost animals that are dogs and stray animals that are dogs is the same. That's the null hypothesis. And we're saying if that were true, what's the probability that you end up with 60% lost animals that are dogs and only 48% lost animals that are strays? Could that happen by random chance? And the answer is no. It can't happen by random chance. The probability of it happening by random chance is 0.000, 15 zeros, 2. Okay? So, I mean, we hate to say probability 0, but this is about as close as you can get to probability 0 as you can. Okay? So we're going to say, okay, the reason why we're getting this difference in proportions of 60% versus 48%, 59% versus 48%, the reason why we're getting that difference is because there is a difference between these two groups and their proportions, okay? And it's not just we happen to get a few more lost animals that are dogs and I happen to get a few more proportion animals that are dogs, okay, or stray animals that are dogs. All right, does that kind of make sense as far as what the proportion test is trying to do? It's trying to establish between kind of just what could happen with random fluctuations and what is actually happening in our data. Okay, so part of the reason why we get such a small p-value is because we have such a huge data set And so I thought, well, what if we just looked at like 1 month in our data, or just, in this case, I looked at just a 15-day time span. Okay, in a 15-day time span, is there a difference between the proportion of lost animals that are dogs and the proportion of stray animals that are dogs? Okay, so here in I have to go through our data, and I'm going to take this column in date, and I don't know if you guys can see, you know, it's stored as like 2019 08 01 000, 2021 03 26 000, 2022 05 11. So it's got this date. It's also got a timestamp, but it looks like the time, it's not actually the time, it's just defaulting to midnight every single day when it inputs something, which is fine. But we need to, right now, I think it's stored as character, okay? So if you look at indate, CHR, character, it's just like, it's the same thing as text. And what we need is, we need R to recognize this as date information. So what, so here, this is the column, or this is the function that's going to create a new column. So we're taking the indate, okay, and I'm going to ask R, and it's actually using the lubridate functions, which allow us to work with date time objects. And I'm going to say, hey, parse the date. And the way the date is stored is, you're going to see the information here is year, month, day, hours, minutes, seconds. Okay, that's what this column is. Okay, if you just say year, month, day, R is going to get confused because it's going to see all of these zeros, 00 colon 00 colon 00, and it's like, I'm not exactly sure what you want me to do. So you have to say all of the things here are year, month, day, hours, minutes, seconds. Okay. Now, depending on how the information is stored, maybe it's just hours and minutes. Maybe it's just year, month, day. Maybe it's month, day, year, hours, minutes, seconds. So you have to kind of specify all of that. But again, lubridate makes it a lot easier. So we're just going to say, hey, parse the date. We're going to take the indate, and we're going to do year, month, day, hours, minutes, seconds. And then, so here, let me just do a view. So this is a very handy thing as you're working with data, is after you do some kind of operation, you can always just pipe the thing into capital V view, and it's going to give you a preview of that table. And you can say, okay, so here's indate 2019 08 01 000, and then let's look at this, and it says, okay, 2019 08 01. So that looks correct, and so that looks correct here, and we can kind of just check and say 2021 03 26, 2021 03 26. So that looks good. Okay. And so what I want to do now is, now that I have the date parsed out, and I've created this new column called date, all right, now I want to filter to a certain year, certain month, certain day. So I'm going to do filter, take the year on the date, and make sure the year is 2022. Take the month on the date and set that equal to June. And the day of the date, we're going to say is between 1 and 15, okay? And so here, again, after each of these kind of things, if you want to just make sure you're doing this correctly, I'm going to say, let's view, capital V view here, and this is what we see. And right away we can see, like, we at least did something kind of correct, because we're down to just only 404 entries, all right? And I can see, all right, is everything here like between June 1st, 2022 and June 15, 2022? So here I'm going to say indate is June 7th, 2022, June 6th, 2022, and we have all of these, all of this stuff here, okay? So that looks good. And then, all right, and so once I have that, let's group by in type, animal type, and then let's create a table, and let's just see how many things here. So in from June 1 to June 15, there were a total of 78 lost animals and 326 stray animals. Of the lost animals, 36 were dogs, and of the stray animals, 125 were dogs. So this time, let's do a proportion test. Is there a difference in the proportion of lost animals that are dogs? What's the proportion of stray animals that are dogs? So in this case, for lost animals, only 46% of them are dogs. For the stray animals, only 38% of them are dogs. And with these numbers, 178 lost animals total and 326 stray animals total, the difference proportion 46 versus 38% is not statistically significant. Okay, we get a p-value of 0.225 or 255, which says, yeah, you know what? It's possible that lost animals and stray animals both have the same proportion that are dogs. And, we're only looking at kind of the first half of this month. We get a different proportion, 46 versus 38%. But that difference is not statistically significant. It could be the result of just kind of random luck. Okay, if you expand the time frame, I think there certainly is a difference in the proportions. But again, depending on how big your data is, if you have a smaller data set, you might not be able to detect such a difference there. So this is how you would go about comparing proportions. I think this is going to be a very useful tool for a lot of groups and a lot of your projects. A lot of times you have some kind of categorical variable and you want to compare the proportion. And even if you have numeric variables, perhaps you want to, you can make categories out of something, right? So maybe you have a numeric variable like age, and you have a numeric variable, say, blood pressure. And you feel like, oh, I've got numeric values, I can't really do anything. But you can say, all right, what if we created a category? People over age 65 versus people under age 65. What if we take the blood pressure and we do people with blood pressures over 140, people with blood pressures under 140? And we could say, all right, if you look at people over age, people with blood pressures over, I'm sorry, what am I saying? Okay, look at people under age 65. What proportion have blood pressures over 140? Let's look at the people over age 65. What proportion of people have blood pressures over 140? And you might see, okay, for under age 65, 30% have blood pressures over this number. Over age 65, 40% have blood pressures over this number. Is there a difference between those two proportions? You can carry out a proportion test like that. And so even if you don't necessarily have categorical variables as of this moment in time, you can create these categorical variables. Okay, sorry, we got to get going. I gave you 1 or 2 view quiz answers. I gave you 2. Okay, the third view quiz answer is the letter E. E as in elephant. E as in elephant. Okay, we'll go ahead and end here for today. We will see you on Wednesday. And again, don't hesitate to stop by office hours if you have any questions with your project.